In this video, we're going to just do a visual exploration and explanation of the second derivative test. So what you're seeing in this plot here is a function that's been given, okay, x cubed minus 6x squared minus 3. We can pick a specific value, maybe a is equal to 1, and we can see here the derivative, the second derivative, and especially at the second derivative and first derivative at the value a. You can compute the linear and quadratic approximations. You should take a moment just to check those now. Okay, I can pause the video and then let you come back just for extra practice. All right, so if you're back, you're familiar with computing a tangent line and the quadratic approximation. And really all we need to do now is to just understand that the second derivative test is trying to be a quick way to figure out when you have a local maximum or a local minimum. So right there on the blue graph, I'm going to move the dotted line black graph, I'm going to move over to that value of a, and you can see that I found a point where the derivative is equal to 0. That's why the red line there is has slope 0. Okay, and then you can see that the blue graph, the quadratic approximation, is opening downward, which means that if you were to zoom in on this graph, that function, the black dotted line, would look an awful lot like a parabola. And that parabola, because of the second derivative being a negative 12, that parabola has to open downward. And that is essentially what the second derivative test says. Compute your second derivative at a critical value, and if that number is negative, you know you have a local maximum. Okay, so let's zoom back out on this function, and we can see over there around 4, if we keep moving over and moving over, right, we're seeing another place where the derivative is equal to 0, and I think it's around at 4. Sure enough, when I put in 4, the derivative becomes 0. And if we were to zoom in on this function, we would see the black dotted line disappear, and it would look more and more like that blue parabola. And that parabola is a parabola opening upward because the second derivative at that critical point 4 is a positive 12, which means that the function looks like a parabola opening upward, in which case the function f of x has a local minimum at 4. So that is the second derivative test. Okay? And all you needed to do was on this function, the second derivative test, was to find the first derivative and figure out the critical values of the function f of x. So I'm sorry, this is the function f of x. I just rewrote f. Okay? So what we need to do is you need to find f prime of x, find the critical values of the function. Okay, we can factor this as 3x, factor out to 3x, x minus 4. And when you set that equal to 0, x comes out to be 0, or x comes out to be equal to 4. As we knew in this problem, there were two critical values. And now the second derivative of x is equal to 6x minus 12. So the second derivative evaluated at 0 is negative 12, and the second derivative evaluated at 4 is equal to positive 12. Since the second derivative at 0 comes out to be a negative number, we know that the function has to be concave down at that point, and the second derivative test says that we have a local maximum at that point. At 4, the second derivative comes out to be positive, which means that the function has to be a parabola opening upward, looking approximately like a parabola opening upward, in which case our function would have to be a local minimum at that critical point. So that is simply what the second derivative test says. Use the second derivative, figure out if it's positive or negative, and that will tell you if your function looks like a parabola opening upward, or your function at that critical point looks like a parabola opening downward. Okay? And that's how you figure out if you have local maximums or minimums using the second derivative test.